Eureka!
The story so far. Objects immersed in a liquid are buoyed up by a force equal to the weight of the liquid displaced. This is called the principle of buoyancy. If the object has the same density as the liquid, it will float in the middle of that liquid. If it is more dense, it will sink to the bottom. If it is less dense, it will rise to the surface. And now, convection.
You look nice and warm. Where does the heat for that hot water radiator come from? The furnace, of course. In the basement. Why is the furnace always kept in the basement? Why couldn't it be in the attic for a change? What would happen if it were? Anyone on a floor below would freeze. That's what would happen. Why is this? Well, let's put the furnace back where it belongs so that we can see how a hot water heating system works. The furnace heats the water in a tank. The hot water rises up through these pipes and into the radiators where it cools, and then the cold water flows down through these pipes and back into the tank where it is heated up again, and so on. But why does hot water go up and cold water go down? Because of the principle of buoyancy.
If you hold something that is less dense than water, such as a cork, in the middle of a beaker of water,
the buoyant force pushing that cork up will be greater than the force of gravity pulling it down. And as soon as you take your hand away, the cork will rise to the surface. Now, when water is heated, its molecules speed up and it expands and becomes less dense. And this less dense water will therefore go up, and then cool and become dense again, and therefore go down. And that's exactly how hot water heating systems work, and why your furnace is in the basement. But the house next door hasn't got a hot water heating system. It's heated by means of hot air. And yet, your neighbor's furnace is also in the basement. Why? Because the principle of buoyancy applies as much to gases as it does to liquids. When air is heated, its molecules speed up, and it expands, and becomes less dense. And so hot air rises, just as hot water rises. That's how hot air balloons work. When the air inside the balloon is heated up, it expands. And therefore, there's not enough room for all of it inside the balloon, so some of this hot air escapes. The result of this is to leave fewer air molecules in the balloon than before. In other words, the air inside is now less dense than the air outside. So the balloon floats upwards, just like the cork in the beaker of water. The fact that hot air rises also comes in useful when cooking a hot dog. It'll take forever to get hot if you hold it beneath a fire. But if you hold it just above the hot air which is rising up from the fire, you're in business. And this is why your neighbor's hot air heating system is able to work on the same principle as your hot water heating system. Hot air goes up. It cools, and the cold air goes down. Since the behavior of gases and liquids is so similar in this and many other respects, and since both gases and liquids flow, scientists refer to both as fluids, and to the type of heat transfer which carries or conveys hot fluids upwards and cold fluids downwards as convection. And it's thanks to convection that balloons go up, hot dogs get hot when you hold them over a fire, and one furnace in your basement is enough to heat your whole house.